We're going to use the eye model to model an intraocular lens now. And then we're also going to visualize the appearance of the intraocular lens from the outside, from the cornea. So let's look at that intraocular lens, which is inserted into the eye first. So I'm going to remove some surfaces here. I'm going to remove the sclera and the retina. And here's my intraocular lens in the green. And we see haptics around that lens. And this is the front of the eye. So we're going to look at the cornea and see if there's any reflections by passing light into the eye and looking at it from the outside. So this is lid appearance modeling. So I'm going to load my settings file from my intraocular lens. So here I've got some settings. Going to use setting number 2 for intraocular lens for my eye model. So here's my number 2. And most of the other geometry is set up similar to the default mode. I'm using a source target. It's unchecked, filling the pupil. And so I click OK. And now I have some particular settings for an IOL in my next input. I can shift the iris if I wish, and then various other geometry associated with the eye. Click OK. Now it's asking me for some more detailed information about the intraocular lens. So I can generate an IOL from some other CAD file and call it here. So I've got a lens called IOL1, and I can also scale that lens. So if it's a small lens and I want to make it larger, I can put a scaling on that, and I did that here, 1.7. I can stretch it on the z-axis. Here I'm just keeping it the same. I can position its anterior vertex, and I can do various other rotations or shift on that intraocular lens as well. I click OK, and it's running, draws the graphic. All right, so my ray trace is complete, and we're looking at some graphics. I did a coherent trace through this system, so we see the coherent graphics, and there's my trace and plot. Here's my isometric plot and my cross sections and my other graph cross sections. Here's my retinal and circled energy. So this is a pretty good IOL, much like a real eye. So in order to do the lid appearance model, I need to take another step with AHEM. I need to export the geometry as a system. So I do that with a system 2 command, and then the name of the file that I want. And now I'm exporting all this geometry and all the media and all the settings so I can process this externally. So I've done that. So the next thing I want to do is load my system file for generating my lid appearance modeling. Where are you? Here it is. All right, so what's going on here now is I've got another ASAP file that employs that system by recalling it. So I've created an entirely new system where I'm going to remove the iris and then do lid appearance modeling. So here's my system from. I bring that back in. I do a numbers name command to find out what my iris is called, and that's what it is, iris.1. So I consider everything in my system except that iris. I create a source, and I trace that through the system, and I select the rays that miss or that leave the eye, or that are leaving the cornea, and I dump that to a reflection distribution file. So then I go into the Breault 3D viewer, and I have my geometry of the eye, which I'm going to zoom into a little bit. And I go here and I say I want to set up my spots analysis preferences. And I pick that file that I just generated up here. I'm going to include all my rays, and there's some various other settings for the Breault 3D viewer for lid appearance modeling. And I say OK, and then I perform a spots analysis. And behind the scenes, that's been put on the clipboard. So I can take that information and go over to PowerPoint and paste that in. And there it is. So let me make this a little bit smaller. So paste that into my PowerPoint. So I have a representation of the orientation of the eyeball here. And then I see a graphic of the lid appearance. And if I make that larger again, let's go back to 100. Let's look at that a little bit. We can see the reflection of the center of the IOL on the front of the cornea. We can also see some reflection of the haptics that were surrounding that intraocular lens. So this is an application of AHEM to investigate reflections off an intraocular lens when the iris has been removed from the eye.